Hello, welcome to Dev Radio. We have Nils back once again. Great to see you, Nils. And
great to see you too, Matt.
We're also here, of course, with Shreya and Bill, the stars of this episode from the Azure Functions team. Specifically, they work on Python and Python tools for Azure Functions. Welcome, guys.
Thank you so much for having us. We're so excited.
Yeah. And today we're going to be talking about, HTTP streaming and the new extension that will help as well. And these are improvements that really help people working with generative AI scenarios. And that's all I'm going to try to say because you're the experts and I'm not. So
yeah, thank you. Thanks, Matt. You hit it right on the head. That's exactly what we're talking about today. So we're going to be kind of showing how easy it is to build intelligent AI apps with some of the new features that we've released here in Azure Functions and specifically in Python. I'm Shreya. I'm the product manager on Azure Functions Python. And with me, I have Bill.
Hey, everyone. Yeah, I'm Bill. I'm a working software engineer on Azure Function team.
Yeah, and we're really excited. So this is kind of what we have for you all today. So first, I'm going to go over very, very briefly about Azure Functions, if you're not already familiar, and kind of just introduce our programming model so that way it's a little bit easier to follow along when we go through the demos. After that, I'm going to talk a little bit about the OpenAI extension, and Bill will demo that further towards the end, but I will give you a little bit of an introduction. Then I'll talk about HTTP streaming and what exactly that entails when it comes to Azure Functions, what some common use cases are, and so on. And then I'll do a Hello World demo for y'all to show you how you can get started with HTTP streaming today. And then Bill will take over and he'll actually share how you can build a more complex end-to-end app using both the OpenAI extension as well as HTTP streaming in Azure Functions.
Great agenda.
Thank you. So just quickly and briefly to go over Azure Functions, if you watched our episode earlier this week, then this might be a repeat for you. But Azure Functions is an event-driven service which provides compute on demand. And it really enables any code or logic that you have to run when it's triggered by different events. Really, with Azure Functions, our goal is that you worry about deploying the code, and the rest is managed for you. So we have excellent observability and monitoring in place. We have dozens of built-in triggers and bindings, which I'll talk a little bit more about as well. But yeah, so with functions, we have something called a function app, and this entity can also be called a project. And within this function app / project, you have many different functions. And this here on this screen is what a function looks like. So we have the trigger, which is required for every function because it invokes the function to run. So this could be like a timer or HTTP, or it could be on some data, for example, with Cosmos DB. And then we also have input and output bindings, which are optional, and they're just what they sound like. They relate to ingesting data or outputting data as well. And then we have the most important, which is your code. That's your business logic. That's what you want the function to actually do. So hopefully these terms kind of help as we go further into the presentation. Next, I'm just briefly going to talk about this OpenAI extension. So it's now easier than ever to integrate Azure Functions in OpenAI. We've very recently released this new extension, and some of the core scenarios that are supported include retrieval augmented generation, so RAG, basically the idea that you can bring your own data for semantic search, also text completion, and chat assistance as well. And this is actually available for all stacks, so not just for Python, but also for .NET, Java, Node, and PowerShell. So Bill is actually going to demo this in more detail and kind of show you how you can use this in your code. But this is just a little bit of, just a heads up that this is what we have released, and we would love for you to try it out whenever you have the chance. Next, I'm going to go into the HTTP streaming feature. So HTTP streaming for Azure Functions is currently in preview. And first, I'll just kind of go over HTTP streaming in general. Basically, it's a mechanism of transferring data over HTTP continuously and efficiently. And it's great when you need to do something that requires real-time processing. Also, HTTP streaming is really scalable, as we know. And now specifically in functions, with HTTP streaming, HTTP requests we're enabling streaming for HTTP requests to and responses from their function apps, using also fast API request and response APIs. This feature is really simplifying the development experience and limiting the resources required on your end, and that will be more clear as we go through the demos as well. HTTP streaming is really, really great for any time you're looking for developing something that requires low latency and high throughput. And it really does allow for that efficient resource utilization. So you'll kind of see that again as we go through. With HTTP streaming, some common scenarios that we see customers using it for include large file uploads and downloads, real-time streaming, as I had mentioned, server-side events, OpenAI streaming, and also multimedia streaming. HTTP, oh yeah, sorry, go
Yeah,
ahead.
sure. And given you mentioned the OpenAI extension earlier, is the HTTP streaming preview linked to the OpenAI extension, or are it two separate features?
Yeah, that's a great question. They're actually completely separate features. So we have the OpenAI extension as one, and then HTTP streaming is specifically enabled in the Python area for Azure Functions. Yeah, and we also have it for Node as well for HTTP streaming.
Thank you.
And actually, one of the reasons that we decided to go ahead and implement this feature is because of a lot of the customer feedback we were hearing, and especially because with the rise of AI and the scenarios that come with it, HTTP streaming can be really beneficial. So even though they are different features, they do go hand in hand, as you'll kind of see in our end-to-end sample. So now I'm going to actually just do a quick Hello World example, just showing you all how you can use HTTP streaming today. Just give me a moment while I reshare my screen. Awesome. Can you all see my VS Code window?
Yes.
Perfect. So here I have two examples that I'm going to start with. So I want to kind of compare and contrast what HTTP requests look like in Azure Functions before we release this feature. So first I have this function app that just uses HTTP requests as usual. And we have this file called helloworld.txt, which is just a sample file with a lot of hello worlds in it. So I'm going to go ahead and actually run this file and show you all what that looks like. So let's go ahead, and I just noticed that my virtual environment is not activated. Okay, perfect. So go ahead and run this for y'all. So yeah, I have this function and then another one that does exactly the same thing, but that does use HTTP streaming.
And I do want to call something out that you're doing here, because I noticed that you're doing func host start. And what's the difference between doing this and running it in Azure?
Yeah, so this is being run locally. When we run it in Azure, you're running it like on the cloud, right? So this is just the local version of that.
Yeah, and I want to call that out to our audience, because this, I think, is one of the very cool things that Azure Functions offers, is that local development environment, where as you're working on a function and you want to test it out really quickly or even integrate it into CI/CD, you can run functions locally or on a CI/CD worker to do a very quick test without having to push it to the cloud and maybe have to wait a couple of seconds or a minute for it to be deployed. This allows you to be really functionally to work very quickly with this. As you can see with Shreya, because she has a function up and running right now locally to test it out.
Yeah, thank you so much for calling that out. Awesome. So with that, I just have my function running, as you mentioned, and I was able to send the post request. And as you can see, the function ran as expected. The data was uploaded and processed successfully. And then as you can see in this log, all of the data was processed at once. So that's, again, one of the differences when it comes to streaming is the data, as you'll see shortly, it's not all processed at once. It is as it comes in, and it can be chunked as well. So now when I share my new function app, this is now the one that does have HTTP streaming. So this one I'm now going to run as well. Let's see. And then one thing I want to call out is here we also are going to use this client library to actually make the script to actually make the streaming call because in this case we're actually uploading the file. So I'm going to go ahead and start my function once again. Yeah, sometimes it just takes a second. And let's see. So now that I have that running, I'm going to go ahead and run the client script as well. So as you can see, it was uploaded, and here we have the same. Now I'm going to go ahead and run this as well. All right, so luckily we saw the same. The data was uploaded and processed as expected. And then as you can see here, as we've mentioned, it was incremental. One thing I want to call out is the time difference between these two requests. So as you can see, well, this is a really small file, but even still, we saw 831 milliseconds here for our first run, and then we saw only 7 milliseconds for the second. So that it does really end up making a difference when you're using HTTP streaming and in that sense as well. And I just really did want to call that out as we go through. The next small example that I want to share with you all is this downloading sample. So with HTTP streaming, we can see an upload and download. And this is a very basic example. I just put it together actually a few minutes ago. And I want to kind of call out how you would go ahead and set up this same sort of thing on your machine if you are using Azure Functions. So first you would start by adding this import statement here. You would also add this package to your requirements.txt. And then you would also want to add some local settings to your code as well. So we have this Python isolated worker dependencies, which is required. And depending on your plan, you might also require a different local setting. But it's really easy to get started. So it isn't like too much extra work or anything like that. As I just showed you all, it's pretty straightforward, and we have good documentation in case you want a reminder of these steps later onwards as well. And so here I just have this function that's going to generate a stream of chronological numbers. I'm going to go ahead and start this function as well. Awesome. So for this one, I'm actually going to share my browser so that way you can kind of see how the data is showing up incrementally. So I'm going to just reshare my screen once more. Awesome. Do you all see this?
Yeah, we see the browser.
Okay, perfect. And so running this function, you can see that I'm getting a generated list as we go on. So if I was not using HTTP streaming, first I would probably set a limit to how many numbers I wanted to count on, and then that's exactly how many it would show me after a pause on the screen. So I hope this helped share a little bit about Azure Functions using HTTP streaming and just kind of the base cases on how you can get started. And now I'll hand it over to Bill, who's really going to go more into detail with a larger demo that is more applicable, perhaps, to lots of different scenarios. So go ahead, Bill. Thank you so much, everyone.
Oh, thanks, Shreya.
Oh, hi. Thank you, Shreya, for the great introduction and demo. And hi, everyone. Again, I'm Bill. Today I want to show you a end-to-end demo of how the HTTP streaming can be integrated and help building the AI apps on Azure Function. So, starting give some context for this demo. We will be using Azure Functions. So we'll create a bunch of Azure Python functions which HTTP is streaming enabled, and we will also be using Azure, the newly released Azure OpenAI extension and Azure function decorators that Shreya has mentioned in the introduction. Want to big shout out to the Azure function team for releasing this awesome work of OpenAI extension and with the new function decorators. this help a function developer interacting with the Azure OpenAI capabilities very easily without writing boilerplate code themselves. So before the actual demo, I want to show you give you more details on the flow of the flow of this demo technically. And here are some architecture diagram I have drawn. So this demo I consider are done in 2 steps. First step, we will be creating a Azure AI weather assistant using the Azure function we set up as shown in the first diagram. You can see we will set up a Azure function binding with the create OpenAI chat assistant trigger. And we will call this function to create a weather assistant in the Azure OpenAI with specific instructions, or you can aka system prompt. So the system prompt I will briefly go over here. Basically, we want this assistant. The instruction we want the assistant to follow consists simple 3 steps. First, if user asks what's the weather of a location, I want the assistant to first find out the real-time weather data of that location. Second step, in the instruction, assistant should send the fetched weather data to the user's Azure blob storage. And in the last step, I want the assistant to stream back a friendly, potentially large and potentially HTTP stream back to the user, along with informing them that their data is fetched and preserved to the blob. What are the things they do, or things they should pay attention when visiting or touring that location in that given weather. So, after the first step, we call this function. We will have a now I'm demonstrating the second step. We will run for this demo. So in the second step, can you see me? Yeah. In the second step, since we have the assistant ready, we will be querying we will play the role of user A as shown in this diagram to send the weather questions to the assistant, and the assistant will process our query following the program instructions. So for example, if I am user A, I want to know the weather of Redmond in Washington State, I can just send a query to this query chat assistant function. What's the weather of Redmond today? And assistant once received the request, it will perform. It will try to following the instructions system prompt. We program it in the step 1, and to carry out a sequential list of things to find out the weather details using the another function we will set up. This function will be calling the weather API.com's real-time API to get the weather details, and then it will, once it get the weather details of that location, it will try to use the SDK blob binding type we set up in the third function to send the weather data to user's blob storage. And once it has done all these 2 steps, it will lastly, as instructed, inform the user that your data is ready to view in your blob. along with some suggestions to turn the local to turn that location in that weather via HTTP streaming. And I want to highlight why we want to use HTTP streaming in streaming this response back. So this response assistant generated can be potentially large, especially if you think of the real world scenarios. When building AI apps, many of these AI apps can require like a low latency, and usually they also process large amount of data back to the client. And HTTP streaming can really help in this case by chunking up the large response on the server side and send the chunks, stream the chunks continuously back to the client, and the client do not need to wait for the entire response to arrive, but they can start the processing the data in real time as soon as they receive the chunks.
And
So,
Bill, if I may ask you a question, if I just think about me using ChatGPT, like when I ask ChatGPT a question, it always sends like it looks like it's typing almost. Like I get like word by word by word by word from ChatGPT. Is that actually using HTTP streaming under the covers to then send me each individual word rather than the full response in one go?
yeah, this is a good question. I believe I do not know the inner details, but I believe that's the case because the GPT are returning like a response with a very large token size window, and you can see like when you see on the in the GPT checkbox, you get the response like continuously, not in one run. And
Yeah.
basically, like the GPT do not wait for generating all the response, but as soon as it generates some of the content, it will use the streaming to stream those content to the client, so you can enjoy like seeing the answers with lower latency.
Okay, thank you.
No problem. Yeah. So given this context, now I'm gonna start the actual demo. Bear with me one moment for switching to the code file. I want to quickly go over the code files I set. So we are using the Azure Python functions and using the function v2 programming model. So I have defined all the functions I mentioned in the diagram in this function underscore app py file. And you can see I've defined the create assistant function. Get this is another function to decorate bound with the AI assistant skill trigger. So this function will be registered to the assistant as a tool for function calling to get the real-time weather data of a given location. And the next function is like another skill trigger function registered for the assistant to send the weather detail to other blob. And I want to highlight specifically here, we are not using Azure Blob SDK directly, but we are using latest released SDK Blob Tab API that was mentioned in the talk yesterday. This is really simple to use. You can add the new function blob extension package in the requirement TST, and then you can like specify the arguments with our blob SDK type, like container client, and you can directly using it to send any data to the blob container. And the next function is the function we will be calling to send a query to the chat assistant. And here are some hyper functions. I will skip for this demo. And besides, so this is the server side setup. And let's quickly show you the client side. On the client side, I have before this meeting, I have written a simple Python script to basically it does nothing but first call the function to create a chat assistant. Then it will ask user for location. They want to know the weather on, for example, Redmond or Seattle. And once it gets the user's query, it will send a request to query the assistant function, and waiting for the function to process and get the response, get the stream, the assistant response back, and print it out to the console as soon as it has received the chunks. Okay, now I will start the actual demo. I have two terminal setup. So I will be running the functions in the server terminal. Yeah, as Neil mentioned, I will run the func start. This is the part of the command from the Azure Function core tools, which you can install. The core tool is like basically a way for developers to install the function runtime binaries in their local machine. And using the core tool commands, you can run the function in a environment similar to the production. So as I run the func start, you can see all the functions loaded and run up and running. Now I will use my client script to call these functions. Okay, you can see the client script has asking me for a location. I want to know weather on. I will pick this time the Big Apple, New York City. Yeah, okay. Now you can see the you can see the function has been processed successfully and streaming the assistant generated response back. Yeah, it's a little hiccup, but yeah, it is following the flow we were expecting. And on the server side, we can verify whether the assistant was doing the things we instructed. So you can see in the log, first we create the assistant, then we send a query. The server receives a request to the user query, and it is the assistant API is smart enough to figure out to call this to do function calling to get the real weather details of New York. And then you can see it also smart enough to send the weather details to the user's Azure blob storage we configured in this demo. And lastly, yeah, as we can see in the other terminal, it is streaming the response back to the user.
Yeah, that's cool to see because you can really see, like, as I think about the demo, like we saw all of the text coming in, like in little chunks. If we would have had to wait till for the full text to be ready, we would have been sitting here waiting for longer for the full text to be available. In this way, as you're building intelligent apps using either Azure OpenAI or potentially any other LLMs. With HTTP streaming, you have the ability to really be very interactive with your customers and don't have your customers sit there and wait on a message. It really just streams to the user and gives you a better user experience.
Yeah, that's a very good point. Yeah. So in this something I want to add is in this demo, we are only streaming like a couple hundreds words, but in real life scenarios or production apps, you could be streaming like a lot more data, and using the streaming can really like reduce memory footprint and allow the users to receive the data. Do not need to wait for the whole data to come back. They can start processing things as soon as they receive the chunks. That's all for my demo. Thanks for going over with me. I will hand back to Shreya.
Yeah, thank you, Bill. This was really good. Thank you.
Yeah, thank you guys so much for having us again. Really hope that like this helped show all of the customers, all of the people watching, how easy it is to build AI apps, intelligent AI apps with Azure Functions using both the OpenAI extension as well as HTTP streaming.
Yeah, totally
Cool.
great. And good links down in the description. And hope to have you guys back next time you've got something new to show.
Cool. Thank you guys so much.
Thank you for having
Okay, cool. See y'all.
See you.